Okay, guys, gals, and non-binary pals. This is Miss Borlaug here, coming to you with types of variables. This is really important. I'm going to introduce some really important vocabulary words and concepts today. So make sure you're paying special attention, and you can even watch this video multiple times. There are a few slides where the image, when I put it into this app for recording videos, it gets bigger than it's supposed to be and it covers it up. I'm not too concerned about it because you're going to have these notes in your digital INB, and you're going to have this slide deck, and I also wrote them in correctly, but my handwriting is a little hard to read with this pen, so I'm not too concerned about it, but I'm going to use the words correctly and everything. So last time we talked about just identifying any variables that could affect your outcome, all the different things that could change, that could affect your outcome. You know, the amount of water, the depth of the lake, the time of day of your test, etc., etc., etc. We've talked about lots of different scenarios. Well, in an inquiry, we're trying to answer a question and gather data and have evidence to answer that question. And so we set up an experiment, and we need to know that, let me see if I'm explaining this right. Well, I know I'm explaining it right, but am I explaining it clearly? All those variables that could change, we have to make it so that only one thing changes on purpose, and we're measuring one thing. So let's look at these plants, okay? Let's look at these plants, for example. The amount of light they could get could change, the amount of water they get could change, the amount of fertilizer, the type of fertilizer, the type of plant, the amount of soil, oh my gosh, what you water it with, on and on and on and on. All kinds of things could affect how these plants could grow, how tall they could grow specifically, okay? But if we want to know how fertilizer affects the height of a plant, then we've got to manage all those different variables in our inquiry. So we need to make sure that it's all the same type of plant, and all the same type of soil, and all the same amount of soil, and the same type of fertilizer, and they're all getting the same amount of water, these 4 drops, and they're all getting the same amount of light and type of light. And so there's names for when we limit these variables in an inquiry. So let me go to the next page. So our essential question is, what types of variables should a good experimental design include? And the first thing that all good experimental designs include is something called an independent variable. Very, very important here. Independent variable. Every true experiment should include the following variables: an independent variable, or IV. And the independent variable is defined as the thing that you change on purpose in an experiment. So in this plant experiment, I'm changing the amount of fertilizer, not the type, the amount. It'd be very important that I use the same type in each plant. Okay? So our independent variable is the thing that you change on purpose in an experiment. Then there's the dependent variable. And the dependent variable is defined as the result or outcome that you measure in an experiment. In this situation, we're talking about the height of a plant. Okay? So we're seeing how the amount of fertilizer affects the height of a plant. Those are the only 2 things we want to change. And only one of them we're changing on purpose. The other thing, the height of the plant, may change, but it may not. We are not doing anything to change the height of the plant except possibly the amount of fertilizer. And so that brings me to the next slide, that's very, very important. Oops, before we do that, let's take a moment to process. Let's talk about, in the left-hand column of your notes, explain the difference between an independent variable and a dependent variable. Try to put it in your own words. So this is really important because I'm about to introduce a new concept, and it's true. We should probably solidify independent and dependent variable before we move on to the next very important concept. Okay, so every good experiment has to have one independent variable and one dependent variable. Let's say that I was changing the amount of fertilizer and also the type. And let's say for this one, I did a different type. I did Miracle-Gro. I don't even know how to spell Miracle-Gro right now. And for the other three, I did, or the other two, because this one isn't getting any fertilizer, and we're going to talk about that. But for these two, I did, what's another type of fertilizer? I don't know. Plant grow. And so I gave 2 drops of plant grow here, and 4 drops of plant grow here, and then 6 drops of Miracle-Gro here. Well, what if this plant grows higher? Do I know if it's because of the 6 drops or because it's a different type? See, that's the problem. You can only have one independent variable and one dependent variable in a good scientific experiment. You can only have one thing that you're changing on purpose and one thing that you're measuring. Very important. Okay, now you're going to pause here. I'm not going to give waiting time here. I mean, I'm kind of slowing down a little bit, but go ahead and pause it here to do this processing activity. And then, okay, you're back. Unpause, and now let's do constants. So if I want to be sure that any changes in the height of these plants is due to the amount of fertilizer, then everything else I have to keep constant. The pot, the soil, the type of plant, the amount of sun, the amount of water, the type of fertilizer, all of those things have to be held constant in order to know that it's my IV that's affecting my DV. In order to know if it's the amount of fertilizer that's affecting my height of my plant. So, let's look at this definition. Constant variables, or constants, are all of the variables that must stay the same between groups so that you can measure the effects of the IV, or independent variable. We're going to say IV and DV a lot. Note, constants are all other variables besides the one variable you are purposely changing that could affect your results. So, if I gave one of these plants less water, could that affect my results? Yeah. So I've got to hold that constant if I want to know that it's the amount of fertilizer affecting the height of the plant. If one of these plants didn't get any sunlight, could that affect the height? Absolutely. So you have to hold that constant if you want to credibly say that the height of the plant is dependent on the amount of fertilizer. Other examples, let's see if I got them all. Amount of water, amount of sun, plant type, etc. All those things need to be held constant. You know, when we brainstormed all those variables, you pick one to change on purpose, you pick one to measure. Everything else has to be held constant. Okay? Now, there's one more important concept when we talk about specific types of variables. There needs to be an independent variable, a dependent variable, and constant, and usually multiple constant variables. But sometimes there's also a control group. And there's not always a control group, but sometimes there is. And sometimes there can be more than one control group. So a control group is the group or groups in an experiment that does not receive treatment and can therefore act as a comparison group. So let me see if I can write that a little more legibly. Act as a comparison, group. That A gets lost a little bit. Comparison group. Okay, so in this lab, this is our control group. Could you have already figured that out? This is the group that gets no fertilizer. Okay, because we want to compare no fertilizer against the rest of these that are getting different amounts. So this is our control group. Without this, we can't be sure that the plant wouldn't have grown that tall without fertilizer. Okay, because my hypothesis would be that this one with the most fertilizer would grow the tallest. This one would grow medium. This one would grow medium but smaller than this one. And this one would grow the shortest. I'm not sure because I'm not running this experiment. I won't have evidence or data, but that's my hypothesis. That's what I think is going to happen. So the plant with 0 drops of fertilizer is our control group. And we can use this plant to compare against the rest. The group or groups in an experiment that does not receive treatment, okay, so treatment would be fertilizer in this case, and therefore can act as a comparison group. Okay. It can be challenging to identify a control group, and that's because sometimes there isn't one. There isn't always a need for a comparison group in a good design. But if there is a need, you need to make sure it's there to make sure that you your results are legitimate and valid. Okay? So, a couple important notes about variables within an experiment. And I've already talked about, I think, most of these, but it's really important to mention again. A fair test has only one IV, or independent variable, only one thing that you change. Okay? I could do this experiment differently, where they're all getting 1 drop of fertilizer, 4 drops of water, but they have different types of soil. And then I measure their height. Okay? I could test a lot of things on these plants, but the important thing is that I'm only testing one independent variable in every experiment. I only have to have one independent variable, one thing that I change on purpose, and one thing that I measure. So these would have to be 2 different experiments. What if I wanted to know how the type of soil affects the height of the plant and how the amount of fertilizer affects the height of the plant? That would have to be 2 different experiments. And one thing I talk about with my kiddos a lot is that that's a lot of times why a lot of medical breakthroughs can be a little slow, is because you can only test one thing at a time, and these trials can take a long time, months or even years. And for medical trials or vaccines and stuff like that, drug therapies and cures and things. And so if I want to, it's very important that you can only have one independent variable in an experiment. You can only be testing one thing at a time. All other variables that could affect your results should be held constant, because you only want your results to be related up to that. So this way, and this is what's covered up, you can be confident that your results are related to the IV. If I succeed at keeping everything else in this experiment constant except for the amount of fertilizer, then I know that the differences in height are because of the fertilizer. If there are differences in height, we'd have to run the experiment to know for sure. So, I think I have covered pretty much everything. Let's see. This is the end of our section. You have 2 processing activities. Number 1, highlight important vocabulary vocabulary words in the notes so far. And number 2, in the left-hand column of your notes, write 1 quiz question about either constants or control groups. Remember that at the last processing activity, halfway through these slides, you wrote about the difference between an independent variable and a dependent variable. Okay, I just got to double check. Oh yeah, we do have a few more slides, that's right. So let me go back, pause here. So pause this video, do these highlighting, processing activities, where one you highlight and one you write a quiz question in the left-hand side. Okay, pause, and we're back, everyone. So let's apply this to our bread mold experiment that we're going to be revisiting as we go through. So in our bread mold experiment, where we're trying to see how effective hand washing and hand sanitizing is on the growth of mold, which we think could replicate the growth of bacteria and viruses, we would, in theory, have 4 groups. 1 slice of bread that's untouched, 1 slice of bread where the hands were washed with soap and water, 1 slice of bread where the hands were unwashed, and 1 slice of bread where the hands were treated with hand sanitizer. So, what would be the thing we're changing on purpose? I want you to think about that and try and answer it on your own. What would be the thing that we are measuring? What would be variables other than our IV and our DV that would be important to hold constant? And do we have a control group? And if so, which one is it? Feel free to pause here. Look back at your notes. Take a guess. Guesses are great. And okay, folks, we're back. You've made your guesses. I'm pretending like you paused there and wrote down guesses. And let's go to the next slide to get our answers. Our independent variable is cleaning your hands or not. Okay, that's the one thing we're going to change, is whether our hands are clean or not. We are going to use 2 methods, but that's okay. Our IV is still cleanliness of our hands, either clean or unclean. But we're going to have 2 data sets. We're going to have a data set with hands washed with soap and water and a data set of hands washed with hand sanitizer. But in each case, we have dirty hands, clean hands, dirty hands, clean hands. The cleanliness of our hands, whether we're cleaning them, no matter what with, is our independent variable. Our dependent variable, the thing we're measuring, is we're going to measure how much mold grows on that slice of bread. Important constant variables, we'd have to make sure that they're all left for the same amount of time. And it looks like I didn't notice, but this slide is truncated, meaning it was cut off here because there's definitely more down here. I will just wing it. Important other constants would be moisture, exposure to sunlight, temperature, location. We would want to try and keep the environment for all of these slices of bread the same. You can see that they're in little baggies. So we'll want to make sure they're all in the same bag. The bags were all the same cleanliness. So probably new bags, or at least washed with soap and water and dried well before we put the bread slices in. You wouldn't want to have a bag that was used and unwashed, even if it was only lightly used. That would invalidate your results. Let's see here. That would cover moisture, because we'd want to make sure the bags are totally dry. Yeah, and what am I missing? Time, location, temperature, sunlight, bags or no bags. I think I'm type of bread. Definitely type of bread from the same loaf, because that means that it's the same amount of preservatives. That means it's the same ingredients. That means it's the same age at the starting point. So definitely from the same loaf. Yeah, I think that's some of the big ones. I'll make a little video in case I missed anything huge. Our control group is number 1. We wouldn't want to see how much mold grew on a slice of bread where we handled it with washed hands, soap and water washed hands, and where we handled it with hand sanitizer treated hands and unwashed hands, without being able to compare it to a piece of bread that had been untouched by our hands. Okay? It's very important. So put this in your notes. And that is the end of our video. Kind of a long one, 20 minutes. But, the concepts of independent variable, dependent variable, control group, and constants are very important. You need to understand that to understand. I hear about science projects. I don't hear about science projects. I hear about, inquiries done on the radio or the news all the time. And I'm saying, okay, so what's their independent variable? What's their dependent variable? Was this a good test? You want to be able to make your own decisions and make up your own mind about things and catch people when they're trying to pull one over on you. You just want to be smart and a good scientist, which you are all on your way to being if you aren't already. Okay, guys. It's okay if you watch this in multiple chunks. I don't know why I'm saying this at the end of the video, because either you watched it in a couple chunks or the whole way through. But if you have another 20-minute video like this, remember that you can always pause it and finish it later after you take a little stretch break or something. 20 minutes is a long time. Okay, and with that said, I'm going to stop talking. Definitely, really, if you didn't fully understand, watch this video again. You can watch it in 2 chunks, 3 chunks, 4 chunks, but make sure you understand everything I said in this video. And if you don't, email your teacher and let them know, okay? Thank you. Bye.